I'm so happy to be here today with Dr. Fatima Abu Salem from the American University of Beirut. Uh, Fatima, you gave a wonderful talk, and we are here to dig deeper into the talk. I would like to note that the audience can type their chat in the chat box, can type their questions. So we will be taking their questions and answering them in this session. And if there are any questions that are left unanswered, we'll make sure to take all the questions and send them to the speaker to address them as well. Let me start with the fake news the fake news project that you presented, Fatima. Is the tool something that you think can be dispatched at the moment for the public consumption?
I think some serious work needs to be done before this can be entrusted to be put at the disposal of individuals. This would be really at a very high responsibility work. Number one, it could be the biases that exist in the data set that we actually collected, which needs to be revisited. It could be the features that we're engineering that people might want to question and contribute to. Publishing that kind of work, I believe, is a separate endeavor than making it public. So in publications, you have 1, 2, 3 reviewers who look at it, maybe decide what's good or bad in it. You come and present it, you get these sort of quick questions or comments. But putting this tool in real, really, requires that we be more careful. And I think the most conspicuous thing I would say is our data set has to be revisited to make sure it's comprehensive enough from the sources that we scrape for, and that the interpretability results actually make sense. And when we're delivering results to say this article is fake, that the user is convinced why it's fake, so that this method can be, or this whole module can be trusted.
Mm-hmm. Yeah. From the Meet the Speaker session, Fatima, we had the following question: which data science tools does your team use to scrape data from the news on internet to identify fake news? Note that the team that works with Fatima, we were chatting a little bit before we started the session, and they are all young female that we are very proud of. They are your RAs, right? So
absolutely.
A shout out to those great women.
Right. Yes,
so back to the question.
Yeah. Mm-hmm. So I'm not sure if I get the question, if it's actually alluding to the technical aspects of the scraping. We did that using Spark on a Hadoop cluster. We've used the new streaming and scraping module, which works on top of Spark streaming, to stream a given source for possible updates or scrape the source for old content. Because at the time when we were developing this project, the war was still sort of going through these peaks that I talked about in my presentation, and we had to go backward in time as well as sort of stream for present news. The module consists of a streamer abstract class and a storage handler interface and a scraper interface. These interfaces are used, and the abstract class and our URL streamer scraper class as well extends the streamer abstract class and overrides its abstract function stream to stream a given news for new articles related to a given set of keywords. So that's on the technical front. If the question is also alluding to how did we make sense of the scraping, like you wake up one day and say, okay, I want to scrape a stream today. As I mentioned, so the peaks in the war that we documented were our guiding reference point, because at the time we thought, if there's going to be any fake news, any contested material, it's got to be about these peaks. Who's done this at that time in that location? And it's got to be a big event, for example, chemical weapon attacks or ethnic cleansing. So the intuition guided the scraping. And no, it wasn't sort of, a random fetching of articles here and there. Not at all.
Mm-hmm. Mm-hmm. Yeah. Again, I would like to remind our attendees to type their questions in the chat. Another question we got from the one of attendees of your talk: how do you make the complex machine learning algorithms that you develop transparent and understandable to the society?
That's a very difficult question that everybody has for us, and we have a duty to answer it in the proper manner. I've noticed that this when we come up to people from other disciplines and tell them we have something nice to offer you, we have these strong analytics tools that can do wonders for you, they immediately have this question for us, like, how can you explain to us what's going on? And so I have to say that there are certain levels how to answer this question. Are we talking about the end user, the layperson who just wants to read about the tool in an online blog or in a magazine? Are we talking about the actual scientific expert whose application requires AI and ML? Are we talking about developers in the same field who want to look at our work and say it's been transparent enough? So I'll probably address each one of them on its own. For developers in the field, co-workers, we really want to make sure, and it's really a piece of advice for young researchers out there, that your data is, if it's a possibility at all, that it's always open, it's clean enough so people can hop on it, that your code is transparent and easy to read and access and run with no trouble. It's really important that people be able to reproduce the work, and here I'm referring to co-workers in the field. For sort of scientific collaborators or maybe general users of the tool, that's where we come at the end and say we're going to invest in machine learning interpretability techniques. If our interpretability exercise shows that for a model that is predicting a higher probability to land in a positive class that you think, the target variable, say I'm predicting this is fake, for example, and my interpretability module says this is because so and so. The model thinks that these were the reasons to make it fake with high, impact. Once the user develops this sort of trust on local instances that are being predicted in the correct manner, then maybe they can come to a stage to say, I trust this tool that you're offering. Whether or not our tool can be explainable in terms of understandable how it's working, I'm afraid that's difficult to do for people who do not come from a modeling background. So they learn to trust the results, and what led this algorithm to release its prediction as sort of a leeway, because they cannot really understand, for example, how a neural network is working.
Yeah. Thank you, Fatima. On predicting needs by Syrian refugees, why was the data not of good quality or size?
Well, because this was data that we received from the Ministry of Public Health in Lebanon. And as many people know, Lebanon is a country that is still reeling from years of war. The infrastructure is extremely challenging to maintain. We've had this data which looked to be sort of manually maintained. The years prior to the Syrian war, there were loads of missing entries and kind of illogical errors. So we had to sort of cut all that out because there was no way we could impute reasonably. And we sort of just focused, luckily for us, the years along the Syrian war were properly maintained, but even then we had to invest in serious imputation. The fact that it's manual, the fact that people come present to primary healthcare centers, say their name, and an officer just jot that down, and allows for a stream of errors and data entry errors that are really a big challenge. The fact that most of Lebanese government's operations so far are still not digitized.
Yeah. And on the same project, predicting needs by Syrian refugees, can you explain the approach you handled to overcome the fact that data was not of good quality or size?
Okay, so that's when I thought that, and I think I mentioned that in the talk, that you have to put yourself in the mindset of the receiver. Let's say this is somebody at the Ministry of Public Health who's given us the data and expects to hear from us, like, what did you do with it? Is it going to do me any good? They're the client. And for us, I think the idea was that the client needs to be prepared, because there was a lot of jargon during those years from a large sector of Lebanese society saying the refugees are, are overstretching our resources. We've been taken by surprise. We can't go there because there are a lot of Syrian demand, refugee so the kind of competition on very scarce resources. And so we thought, okay, we need to focus on our models being able to predict very accurately those relevant instances that show high peaks, because that's when people need to be prepared. And we went there and realized that there isn't enough in the sort of traditional machine learning literature that addresses imbalanced learning for regression. But we've seen a lot of it happening in non-ML, more on the statistical learning part, for example, across the lines of black swan theory and utility-based regression, which says, fine, we will artificially maybe overpopulate, oversample what we think is the majority class. This is a regression, but we have a range that is rare and relevant, and that we will define to be, the minority class, not the majority. And we will synthetically overpopulate using machine learning to expose the model to more instances of that. We will define instances of precision and recall and show that our models are not just accurate with a high R squared, but we're able to achieve a high recall to convince the user that never mind the overall performance, we are able to capture the days when demand is really going to be high, and we know why is that happening in time and space.
Mm-hmm. Yeah. And you alluded to time and space connections quite frequently in your talk. Can you explain the intuition behind that?
Okay, great. Again, this is all from the eyes of a local. When we lived through these junctures of the war, and we would hear people saying, "Oh, there's influx across the border into that region in Lebanon because from the sectarian map this works well," and at the time, I thought, do we want to maybe explain and analyze the data and show, is the spread of, demand? I mean, we sort of inferred if the demand is high in these locations, it means there are more refugees there. So somehow indirectly, you could tell about the spread of where people are going, because we didn't have any record to demonstrate where people are, where the densities are. And then we thought, okay, maybe if we just link it to time and space and show a compelling argument that it's not really about the sect or the sort of ethnicity of people. These people are just fleeing to locations that are closer rather than more sort of places where they could have kind of more homophily kind of associations with it. That was an important kind of motivation for us. That most of these fluctuations are really a matter of being temporally associated with the large-scale operations and being sort of close to where the events happened, rather than maybe something else to do with ideology or sect.
Mm-hmm. Yeah, thank you. Back to the fake news project. Can you elaborate more on the features you are engineering to allow for automatic fake news detection by machine learning models?
Right. So if somebody is a researcher in fake news, automatic fake news detection, most of the literature is sort of Western-based. The resources are Western-based. Even the linguistics associated with the terms that the community has engineered around automatic fake news detection, they tend to be more universal than not. But we thought that we have an extra layer of complexity to add, because this is a war in the Middle East with sort of freedom and democracy at one side of it, but also at the other, locals would see that there could have been also some sectarian nuances in the way that the conflict eventually deteriorated into, unfortunately. And so we thought about this sort of sectarian lexicon to build. And very much like you would say, is this article biased? I would ask, is this article more sectarian in language? And does that play a role in its classification into fake or true? Also, the inconsistency. So if several, the inconsistency feature, which said if several articles from the same media camp, let's say pro-regime, came out to be inconsistent among each other with respect to ground truth, we have reasons to think that this inconsistency is a really an indication that the articles might be fake. Those were some of the two guiding features we went by to try and bring the fake news detection more sort of into the context of the actual war and the region.
Yeah, thank you, Fatima. We have a question from Victoria Naipal. She just sent it to us. Victoria says, thank you, Fatima, for the answers to the previous questions. My question about machine learning transparency was more about the fact that the general public, no scientist or developer, do not trust it because it is more of a black box. I think if we would be able to build a machine learning application where one would be able to follow the different steps of how the algorithm transforms the data into valuable information, it would be more accepted and used in the proper way by people.
Absolutely. But again, I mean, I teach a data science course for people who come with little background around this. And that's, in certain places, I feel more comfortable. Sort of in rule-based systems, it's very easy to convince people that this is how my model arrived at its final verdict. Even, dummy models like KNN and, like highly rule-based like decision trees, they're fine. I think they are inherently ready to be exposed to the public and say, this is what we're doing. But on the aspects of ML, like say black box and neural networks and support vector machines, I think I'm not the right person. I haven't worked on rule extraction algorithms for neural networks and support vector machines, but I know for sure that long before modern interpretability techniques like SHAP and LIME, etc., have existed, there have been decades of work and publications on rule extraction for neural networks and support vector machines. Personally, I haven't delved into that, and I think if the need arises and we have an obligation, we probably should invest. But up until this moment in time, I think we've managed to get away with saying, I'll explain it using how my decision tree, for example, or KNN, arrived at its conclusion, or else do some nice SHAP visuals to show the effect of each variable on the target variable prediction. Beyond that, I personally have not been investing. Maybe I should with time, who knows?
Yeah. Back to on the Turk Telecom project, Fatima, that you talked about in your presentation, what were some of the major events in the Turk Telecom project where we saw peaks in refugee mobility metrics? And do the results make sense?
Right. The Turk Telecom data was given to us only for across a year. So there wasn't really a lot to see as much as we've seen in the Ministry of Public Health project. But again, the boost in call durations that we observed happened during the month of November of that year when we 2017. This is when the Eastern Syria campaign was launched, which is a large-scale military operation to free the city of Deir ez-Zor. This was also at a time when the region of Eastern Ghouta, Al-Ghouta al-Sharqiyya, was extremely short on food and supplies. And at the time, we thought these were really monumental events. We recall when we were here, listening to the news and sort of making sense of all of that. Yes, that time in the year, things were really, really bad. And that's really at the humanitarian level rather than frequency of air bombardments or other forms of attacks. So we've noticed that most of these peaks are associated with calamities on the ground, people under siege or being short on food and supplies. And for us, that was an intuitive thing to convince us that, yes, the results seem to make sense. I have to say, the Turk Telecom did not progress into a predictive analytics project. For us, it was more like exploring the data and making sense of it, which I think was equally, if not more important, than enforcing a machine learning module on top of it and trying to do any kind of prediction. With 1 year, there's little you can do. But with time, I think people might learn the prototype and say, if we link these observations to what's happening around us, we can be better prepared for relief operations.
Right. On the same project, Fatima, a little similar work tackling this type of data has been done elsewhere. And so it is difficult to assess how well a machine learning model is performing. What are some of the techniques that you follow to ensure that the models you're building are sufficiently skillful?
Okay, so on the technical front, we always need a baseline performer. So for example, in the fake news dataset, we had to go and run some modeling on purely text-based models like BERT, for example, models that did not require any of the features that we engineered, and see what the result is. And because we're also doing meta-learning, the baseline would tend to be your vanilla, good old models that are just there. I mean, they're designed for a good type of data, for a good spread, a good balance between classes, you name it. So there's always baseline, and the performance can only be described relatively speaking. Even if you get a high accuracy, well, of course, this is to answer maybe beginners. Your maybe learning curves would convince you that despite that your data is tiny or small, you're still generalizing, you're doing well, and things like that.
Yeah. We have 3 more minutes. So Fatima, can you, while waiting for questions from the audience, can you tell us about the challenges affecting women in this field, being a female data scientist in this region, working in this region? What are some challenges that you see for women working in this field, and where do you see yourself going forward?
Okay, so the challenges, of course, that every maybe female would be identifying with. For example, imposter syndrome issues where you think maybe you're not good enough. If you're working in a field that is very male dominated, if you don't see enough leaders from your own gender or race or group, I think these are universal things that still affect a lot of us. I mean, I'm involved in a couple of mentoring projects, and at the beginning I thought it's only me, and then I realized it's almost everybody. The fact that you have to juggle life and work, and again, mostly universally, most of the responsibilities still fall upon the shoulder of the mother. So these are universal things. But for us in the region, I think you have an added layer of complexity, of having to do good science, and some of the most challenging, under some of the most challenging circumstances ever. And they're not just circumstantial, they just go on, and you find yourself having to, meet up universal expectations, like you've got to publish in high-end venues, you're working in a very fast-paced field, and to do that while you're worried about your livelihood every day is some of the, I think, most difficult things that can happen. And if I were to bring it down to gender differences and how men versus women approach these conflicts, again, I don't want to make general statements, but I tend to believe that women probably panic more when it's sort of an issue that is going to affect their family's livelihood as opposed to men.
Yeah. Thank you so much, Fatima, for this very informative and insightful discussion. Again, for the attendees who have any questions, please send us your questions we'll communicate them to Fatima, and you will have your questions answered. Thank you so much, Fatima. I completely agree with what you're saying.
Thank you.
We both work here at AUB, and yeah, it's challenging, but we together we can make a difference. So this is what WIDS is for and aims for. Thank you so much, Fatima.
Absolutely. Thank you.